Alright, we're going to graph linear inequalities. And this is very similar to graphing linear equations. The only difference is we're going to do a little shading here because there could be multiple solutions. Alright, let's copy down example 1. We're doing this on graph paper. So apples cost $2 per pound and bananas cost $1 per pound. You plan to spend no more than $8. How many pounds of each can you buy? Alright, first off we need to define our variables. So I'm going to let x be my number of apples and y can represent my number of bananas. Alright, and it says no more than, so no more than is either that amount or less. So that's called less than or equal to $8. So now I'm going to write the equation, or the inequality rather. So write the inequality, and that would be 2x because it says $2 per pound, so that's 2x plus y less than or equal to 8. After I've written the inequality, I want to solve for y. So if I subtract 2x to both sides, I will get y is less than or equal to negative 2x plus 8. Alright, now that I have it solved for y, I know my slope and I know my y-intercept, so I can graph it. So I'm going to start by graphing my y-intercept. I go up 8 on the y-axis and put a dot. Then I'm going to use my slope, which is negative 2 over 1, and that rises down since it's negative, and the run is to the right since it's positive. So down 2, right 1, down 2, right 1, down 2, right 1, and down 2, right 1. And I only care about the positive values, so the first quadrant. And the reason is you're not going to buy a negative poundage of apples or a negative poundage of bananas. Hopefully that doesn't make any sense to you, right? So now I'm going to graph this. Since it says equals to right here, it's less than or equal to. That tells me it can equal every point that's on this line. So I'm going to fill that line in, make it a solid line. And this is less than, so where do you think the values would be that are less than? If you said under that, you are correct. So I'm just going to shade under that graph. And I can shade all the way under it, but I really only care about the values that are positive. The other ones don't make sense. So I just shaded under that graph. And this tells me that, and I'm going to label these axes for you so you can make sense with it. This is apples, is my x-axis, because we'll let x be apples, and bananas, B-A-N-A-N-A-S, is our y-axis. So let's say you had 2 pounds of bananas and 1 pound of apples. That could be a solution. So that would be $2 plus, what's that? $2 for apples. That would be a total of $4. And then any points on the line are going to represent exactly $8. So for instance, up here at this point, 1, 2, 3, 4, 5, that'd be 6 bananas, just so you can get a visual of this. So 6 bananas, and they're $1 a piece, so that would be $6. And then how many pounds of apples is that right there? We'll look straight down. That's 1 pound of apples. So 1 of apples would be, they're $2 a piece, so that's another $2. 6 plus 2 gives us 8. So everything that's on that line is $8. Everything under it is going to be less than 8. Alright. Alright, next I want to talk about how to graph these specifically. So, for instance, if we have a, well, first let's just talk about types of lines. So if we have a greater than sign or a less than sign, these are going to be dotted lines. And this means that points on the line are not solutions. All right, well, what if we had greater than or equal to or less than or equal to? Well, if the other one was dotted, then that means these are going to be solid lines. And this means that points on the line are going to be solutions. All right, so that previous example, we had $8 to spend. So that was a solid line because we can spend $8. But there's some times when it's just going to be greater than something or just less than something. And there, our line is not going to be a solution. All right, next thing we're going to talk about is types of shading. So greater than or equal to, they are shaded above the line because they're greater than all those points. And then, you may have guessed it, less than or equal to are going to be shaded below the line because they are values that are lower than the line or less than the line, so they're under it. All right, so our example for that, on this line, let's say it was a greater than or equal to. Well, we already know it's a solid line because of this, because it's equal to it. But since it's greater than, we're going to shade everywhere that's above that line as a solution. So all these points are solutions. Just draw a simple sketch there. And now let's do another example where it's going to be less than. So if we're graphing less than on this graph, it helps for me to kind of either tilt the paper or tilt it visually so that that's more of a flat line. And now you know that under that's going to be down here. That's below the line. And again, just tilt that. So if it's like that, just make it a little more flat, but still a negative slope, and you can see it's going to be shaded below that line. And then if I tilt it back, I'm just going to continue to shade that below the line. These are all solutions below that dotted line. And that's how the shading works. Now I will show you another way to do shading, and you can choose whichever way works best for you. Me, I'm a visual person, so the shading I just showed you makes sense to me. But a lot of students I've taught prefer this method. So the test point method, I'm going to call it shading with test points. And what we do when we shade with test points is to actually make up points above or below or on the line. So make up and plug in ordered pairs above or below the line. And what that's going to do is, if it works out to be true, it's going to be a solution. So we'll say true is a shaded solution. And false, you may have guessed it. If it's false, it's going to be unshaded, and it's not a solution. So if you get a false point, you shade the other side, in other words. So it's unshaded, and it's no solution. All right, let's try a quick example with that. All right, so our example, y is greater than negative 2x plus 1. All right, well, first we're going to graph it, or at least graph the line anyway. In graphing that line, I'm again going to use my y-intercept, so it goes up 1. And then my slope is negative 2 over 1, so negative 2 over 1 tells me down 2 and right 1. So I go down 2, right 1, down 2, right 1, or I can go the opposite, which is up 2, left 1. Up 2, left 1. All right, so, and I know it's a dotted line because it doesn't have that equal to symbol. All right, now about the shading. How do we do this test point thing? Well, pick any point that's above it. So I'm going to pick a point above the line. Let's say I can clearly see that the point 1, 3 over here is above the line. I'm just choosing a point. And honestly, you can pick any point. Just make sure it's clear to see whether it's above or below the line. And I'm going to write down that ordered pair, so it's 1, 3. And I'm going to test it. The 1 is my x, the 3 is my y. So I'm just going to plug those in. So y is 3. I'm going to see if 3 is truly greater than negative 2 parentheses, plugging in a 1, plus 1. So use order of operations, simplify that out, and you get negative 2 plus 1. And let's continue to see if that's true. Negative 2 plus 1 is negative 1. 3 is greater than negative 1. That's true. So since that's true, that means I can shade that side. So that means I'm going to shade everywhere above that line, since that was true. If that would have been false, I would have shaded the opposite side. I would have shaded over here. But that was not the case, so I just shaded up there. And that's how the test points works. So plug in an ordered pair for x and y. If it's true, shade that side. If it's false, shade the other side. So pretty simple, right? All right, our last topic for today is going to be graphing systems of inequalities and solving them. So graphing systems of inequalities, the first step is we want to make sure that they are solved for y. In other words, convert it to y equals mx plus b. And yeah, I know we're not going to get an equals, it's actually an inequality, but I think you get the picture. So slope-intercept form. And then second, we want to find out where they are both shading. So it's the solution is where both graphs are shaded. It's the region where both graphs are shaded. Alright, so again, first step, convert to y equals mx plus b. Second step, the solution is the region where both graphs are shaded. And that's really all there is to it. So let's try an example out with that. Alright, so our example is solve 2x minus y less than or equal to 4 and y less than negative x plus 4. Alright, are they both in slope-intercept form? No, that first one's not, so we need to convert that first one. So for my first step, I'm going to write 2x minus y less than or equal to 4, and I'm going to solve for y. So subtract 2x to both sides. 2x's cancel. I'm going to bring down a negative y, and that's negative 2x plus 4. And I don't like that negative in front of the y, and I know that's a negative 1y. So I'm going to divide that negative 1 to everything. And recall from a previous unit when we solve inequalities, if we multiply or divide by negative number to either side, then, or to both sides rather, then we need to reverse the inequality. So that would be y is greater than or equal to negative divided by negative is a positive 2x. 4 divided by negative 1 is minus 4. So that becomes y is greater than or equal to 2x minus 4. Now that I have them both solved for y, I'm on step 2. I want to graph both of them and see where they are both shaded. That's going to be my solution. So using your graph paper, we're going to make a little sketch of these guys and see where they cross. So I'm going to graph the one on the left first. So my y-intercept is 4, so I go up 4 and put a point. Then I go down 1, right 1, because my slope is negative 1 over 1. And remember, that means down 1, right 1. And I'm going to graph a few to the right and a few to the left. So up 1, left 1, up 1, left 1. That should be good. We'll find out in a minute if we need to adjust it. And now I'm going to graph my second inequality. So -4 is my y-intercept, so I go down 4 from the origin. My slope is 2 over 1, so that means I go up 2 and right 1. So up 2, right 1, up 2, right 1, up 2, right 1. We've already crossed it, up 2, right 1. And that looks pretty good. So they do make an X. They do intersect. So there is going to be one solution. If they were lines, there would be one solution. But since these are inequalities, there's going to be an infinite number of solutions. All right, that second one we just graphed, let's talk about, I'm just going to look at it. It says greater than or equal to, so that means I shade above it. So for that one, I'm going to shade like this, above those green dots. And then for my blue line, and one more thing, that was a solid line right there. So I'm going to fill that in right there. All right, next up, on my first graph, I noticed that's just a less than. So I'm going to shade everywhere below the blue dotted line. So everywhere below it is going to be this region right here. Now where did those two shadings intersect? I'm going to shade that all in black. You can see right here is where those shadings intersected. So you can just darken that in with your pencil on your graph paper, and that's going to be the solution to these two inequalities. And that wraps it up. Oh, you think that means you're getting a present? No, it's just a saying. Now I hope you've gotten wrapped around that concept.